Hi friends, I'm so glad you're here today. Today we're going to be talking about factoring. We're going to be talking about three different things today. The first thing we're going to be talking about is the greatest common factor. Hoping that this sounds pretty familiar to you. Just want to jog your memory since it's probably been a while since we've had to do this. Greatest common factor is the largest number and or set of variables that two or more expressions have in common. So those expressions could be monomials, they could be binomials. We're looking for things that can be divided out evenly. So when we look at this problem right here, 40a squared minus 32a, we're going to look at this problem in pieces. First, and you don't have to, but for this tutorial we're going to. So when we look at 40 and 32, we think what is the biggest number that can divide these? And some of you might be really good with your math facts and be able to tell me the biggest one really fast, but if you can't, it's okay. You can just find smaller numbers and take them out kind of in chunks. So if you don't know the biggest number that these have in common, but you do happen to notice they're both even, that means we can take out a 2. So if we take out a 2, and that just means we're going to be dividing by 2, your greatest common factor still has to remain part of your problem, goes on the outside of your parentheses, and then we do the division, so we would be left with 20a squared minus 32a. So you know you found the greatest common factor when what's left over in your parentheses here no longer has anything in common. So when we look at 20 and, 16, we notice that they're both still even, which means we can take another 2 out. But you also might notice that besides a 2, you can take a 4 out of both of these. So again, when we say take it out, we mean to divide it. So the 2 that was here originally is going to stay, and now is going to get multiplied with that 4 we're taking out. So that would give us 5a squared minus 4a. Now you might currently be screaming at the screen to tell me that not only do these have numbers in common, they also have letters in common. But if I look at my numbers first, I notice that 5 and 4, there are no numbers I can take out to divide those evenly anymore. So that means I've found my greatest common factor, which is going to be, the number bit is going to be 8. And you may have noticed that these both have a's, so a is also part of our greatest common factor. So this one has 2 a's and this one has 1 a. So they both have 1 a in common, which is going to be part of our greatest common factor. So when I take that a out, now I have 2 times 4 times a, so I have 8a. And then what I'll be left with when I divide by a is just 5a minus 4. So this right here is the factored version of this guy right here. So remember, factoring just means to find two things that would multiply together to equal the product that you are hoping for. And if I distribute this, I will get exactly that. All right, so let's try one. So if I had 3x cubed minus 12x. So again, you can look at this in bits, in the number bits, and then the variables, you can kind of mix them together. If I look at just my numbers, I notice that 3 and 12 are both divisible by 3. And if I look at my letters, this one has 3 x's and this one has 1, so I know they both have 1 in common. So my greatest common factor is 3x. So if I divide both of these by my greatest common factor, keeping my greatest common factor as part of my answer, we'll be left with x squared minus 4. So these two things multiply together to equal our original product, and that's how we know it's been factored. And we also notice that there is nothing in common left inside my parentheses, which means we've actually taken out the greatest common factor. Now this right here is a really good segue into what we're going to be talking about next. So besides taking out greatest common factors, we're also going to be looking at something called a difference of squares, a difference of 2 squares. So a difference of 2 squares is called a difference of 2 squares because difference, meaning subtraction, two, because we have 2 things. This is a binomial, has 2 things. And then the difference of 2 squares means that each of these pieces are perfect squares. So x squared is a perfect square because it literally has squared in the name. X times x gives us x squared. And 4 is a perfect square because 2 times 2 gives us 4. So when we factor these, we can actually think about them as trinomials, which a lot of you guys are really good at factoring. So this is a trinomial if you squeeze that 0x in there, because there's no 0 term, or sorry, there's no x term, so we can make it a 0. So then we got to find two things that are going to multiply together to give us this trinomial. So what multiplies to give us x, 1x squared, would be 1 and 1. So 1x and 1x. The factors of 4, 1 and 4, 2 and 2. And then the factors that are going to, or sorry, the signs that are going to multiply to a negative are a plus and a minus. Now this one's pretty, the numbers are pretty small, so you might be able to figure out the answer pretty quickly. But if we just use some logical thinking here, because you know that's what I'm all about, in order for us to get 0 in the middle, the only way to get 0 when you're adding two things together is if those two numbers are opposites of each other, like 3 and negative 3, 8 and negative 8. So we are looking to multiply things together that will create opposites. So 2 and 2 are going to be the thing that creates those opposites, because you'll have a 2x and a 2x. We already know that we need a plus and a minus. So that would give us x squared minus 2x plus 2x minus 4. These guys will cancel out to give me 0. And we know that this has been factored correctly because it multiplies together to give us that product. Now that's a little messy, so let's look at another one. Okay, so again we have a difference of two squares. So x squared is a perfect square because it's x times x. 49 is a perfect square because it's 7 times 7. So x plus 7, x minus 7. One has to be plus and one has to be minus because we're trying to multiply to get a negative. So you might notice that really I just square rooted both of these things, and that's what went in their place. So what happens if instead of x squared minus 49, it's 9x squared minus 49? Well, first thing we need to check, is this a difference of two squares? Is it subtraction? Sure is. Are there two things? Yes, it's a binomial. And are both of those things perfect squares? So this whole thing, right? 9 is a perfect square, x squared is a perfect square, which means this whole thing is a perfect square, and 49 is still a perfect square. So square root all those bits, we're going to have 3x plus 7, 3x minus 7. Okay, a couple iterations. What about x to the 4th minus 81? Well, 81 is clearly a perfect square because 9 times 9 is 81. But what about x to the 4th? Are there two identical things that multiply to x to the 4th? Yes, x squared times x squared. So x squared, 9, 9, 1 plus, 1 minus. So it doesn't matter which one's the plus and which one's the minus as long as you've got one of each. So there's lots of things you could do here. I could add a y squared to the end, and now we'd have x squared plus 9y, x squared minus 9y. Lots of things that you could do in this space. Okay, the last thing we're going to talk about is called the sum and difference of cubes. Now you may notice that I didn't give you a sum of squares formula. There are no real number factors if you have the sum of squares. So we'll talk about that maybe in another lesson, but right now we're just dealing with real number factors. So on our real numbers, not imaginary. So the last thing we have is the sum and difference of two cubes. Okay, so this one actually is two different possibilities. You could have cubes, a cubed plus b cubed, or a cubed minus b cubed. So sum of two cubes, difference of two cubes. So these, I'm not in love with these because it's kind of just a formula you have to remember. So I'm just going to give you that formula and then we'll just practice it and hopefully commit it to memory. Okay, so if you have the sum of two cubes, you cube root this guy and cube root that guy. So the cube root of a cubed is a, and the cube root of b cubed is b. Notice I'm not filling the sign in yet. And you also may notice that this parenthesis that I drew is a little bit longer than that one. That's because this one's going to have three things in it. This is going to be a trinomial, and this is a binomial. So in my trinomial, once I've gotten these bits, now I'm going to square this I'm going to multiply these two things together, and then I'm going to square that. Now, your signs follow the acronym SOAP, and that's same, opposite, always positive. So what that means is this sign is going to be the same, this sign is going to be opposite, and this sign is always going to be positive. So any sum of cubes will factor in this manner. So if we had 8x cubed plus 1, short parenthesis, long parenthesis, cube root. So the cube root of 8 is 2, because 2 times 2 times 2. X, cube root of 1 is just 1. Now I take these to fill in this parenthesis, so I'm going to square this. So that means I'm not just squaring the x, I'm squaring the 2 as well. So 2 squared, x squared. Multiply these two together, a times b, and then square this guy. And then I'm going to SOAP, same, opposite, always positive. So I got a plus, opposite, always positive. So this is how this guy factors. Now the difference of cubes is actually pretty identical, except this changes, but the sign acronym stays the same. So a cubed minus b cubed would be cube root, squared, multiplied, squared. The only difference is what the signs look like in here, but you can still follow this acronym. So same now, this is same, so it'll be negative. This is opposite, so that's positive, and this guy's always positive. So all cubes, sum and difference of cubes, will factor similarly to each other. Really the only difference are the signs. All right, so I'm going to give you some practice problems, and we'll see what we can do from there.